Hello and welcome to today's lesson. Today we're going to be covering Chapter 8, Lesson 3. And we just recently talked about proving triangles similar by angle similarity. And now we're going to add to that side similarity and side angle side similarity. All right, so the first one we're going to talk about is side similarity. So if we have two triangles here, like we look down in the bottom in the blue and the red, and we know that the corresponding sides, so like AB and RS, have the same scale factor as AC and RT, and then they have the same scale factor as BC and ST. So they all have the same scale factor to show the sides are proportional. Then we would say that these two triangles are similar, and we call this side similarity. You must absolutely put this similarity, because if you just do side, that says that the triangles are congruent. And it is very evident that they are not congruent. They are similar. All right, so are these triangles similar? So what I like to do is set up the ratios of all three sides, and I do the shortest sides, and then I do the middle sides, and then I do the largest sides. So in this first triangle, the shortest side is 8, the medium side is 12, and the largest side is 16. Then I do the same exact thing for the next one. So we have 6, the middle side is 9, and the largest side is 12. Now we see, what does this reduce to? Well, this is going to reduce to 4/3. Divide by 3, we get 4/3. Divide by 4, and we get 4/3. So all the sides are in the same ratio, and I'm proving it by showing you the ratios and what it simplifies to. So yes, they are similar by side similarity. All right, now let's go check the bottom one here. And again, I do the smallest side is 8, the medium side is 12, and the large side is 16. Over here, the small side is 8, the medium side is 10, and the large side is 16. Well, we can see right here, these are not in the same ratio, so this is not similar. All right, find the value of x that makes the two triangles. So I personally like to say AB and DE. So I get those two kind of coordinated in my brain, and BC, so I'm using these two letters, BC, and the back two, EF. And this one, nothing tricky is happening. The left sides, the right sides, the bottom sides are all corresponding. It's when they give you triangles like this, and they're opposite. So when they say this side is similar to this side, that you're going to want to make sure that you use those letters. This one probably won't be too difficult to figure out. So it just depends what you want to set up here. So I'm going to do the black sides, 4/12. Okay, left side, and then I'm going to do x minus 1 to 18. And we solve this by cross multiplying. So 18 times 4 gives us 72 equals 12 times x minus 1. And we're going to have to distribute over here. So I get 12x minus 12. So I'm going to add 12 to both sides. Looks like I'm going to get 84 equals 12x, and when we take 84 and divide by 12, we get 7. So x is 7. Okay, you could of course set up some other ones. So I could have set up the black, and the black still did that, 4/12, and then I could use these bottom sides, 8/3 times x plus 1. So we could have cross multiplied and solved this way also, but you really only have to do it one way. All right, moving on. The next thing is the side angle side similarity. So just like when we were doing side angle side congruence or angle side angle congruence, we talked about the included angular side. So in this first one, we're talking about the angle that is included between the two sides. And in the second one, we'd be talking about the side between the two angles. So it is super important that you go right in order. Side, angle, side. Okay, we can't be skipping around here. So when we look at these two triangles here, they are telling us that this side, XZ, is in the same proportion or ratio to MN as XY is to MN, and then we have the included angle. So this is what makes this one be the side angle side similarity. And again, the similarity is super important because we are not talking about congruence. We're talking about two different size triangles that their angles are congruent and their sides are in the same ratio. All right, prove informally. So basically just stating, are we going to show angle similarity? Are we going to show side similarity? Or are we going to do the new one that we just did with side angle side similarity? So we're just going to start in here, and we've got angle F is congruent to angle A, both 53 degrees. So I guess that would lead me to believe that we're probably not going to be doing the side because we have an angle in here. So now we have FG to, what does FG compares to AB? So that's in the ratio of 6 to 9. So if we divide by 3, we get 2/3. So now we got to check that other side ratio. So over here we've got FH, and how does that compare to its corresponding side AC? So we have 10 to 15. So if we divide by 5, we get 2. If we divide by 5, we get 3. So looks like we have a side and then an angle and then a side. So we have shown mathematically that both sides have the same ratio and the angle between. So this is by side, angle, side similarity. All right, that about wraps it up for this lesson. So just remember that we have now added, we've got angle similarity, side and side angle side. Remember the similarity at the end, otherwise we are saying things are congruent. All right, good luck on your homework.